Hi everyone. Today we're going to solve the lead code problem number 36, valid Sudoku. This is a really easy problem, but there's a clever little trick that I'll show you, which can be used in many other problems as well. So let's first look at the problem. Let me go to the page. Yeah. So the problem says determine if a 9 by 9 Sudoku board is valid. And it's, the most important part is only the fill cells need to be validated according to the following rules. So we don't need to actually solve the Sudoku board, but just check if the already existing numbers, uh, which are in the input, are according to the rules of the Sudoku game or not. So each row must contain the digits 1 to 9 without any repetition. Each column should also contain digits 1 to 9 without repetition, and similarly, each of the 3 by 3 sub boxes should not have any repetition. And notice a partially filled board, right? So this is like a partially filled board in the example. It could be valid. We could validate it, but there's no guarantee that we could get an answer for this. It's not necessarily solvable, and only the filled cells need to be validated according to the mentioned rules. So let me just copy this. Let me copy this and then paste it here so that I can explain. Okay. So essentially, the way we are going to look at the problem is, of course, we would need two loops. So the loop one would iterate over the rows, and the loop two would iterate over the columns. Okay. So then after this, we need to do a check on whatever is at board RC. Okay. So let's look at what check we can do and what we have to do. So essentially, the three conditions are: one, we should uh, no repetition in same row; no repetition in same column; and third is no repetition in same subgrid. Okay. So by this term, no repetition, right? One clue we can get here is that we can use a set. Okay, so at least for the rows and calls, right? Let us use a set to, one set uh, per row, and again one set per call to keep track of the numbers. Okay, so like it would look something like, in this check our check, right? So it would include three checks. So if BRC in rows of R, where R is our, rows of R is the the set for the particular row, and if it's already there in the set for the particular row, then we continue onto the next uh, onto the next cell. And similarly, if board RC in calls of C, then again we continue to the next one. Or I mean, okay, so Okay, so I'm rather than continuing, right? So let's try to cut short the code a bit. So if this number already exists in the row, right? So then we can just return false, because in that case it would be yeah, in that case there would be a repetition, because you would already have one element before, or one number before, that has already occurred in the same row. Similarly here, right, return false. Okay, but if it's not there, right, then we need to add it to our uh, two rows of our. Okay, so we need to add uh, br comma rc, two rows of r. Similarly, we need to add uh, brc, two calls of c. Okay, so these are the two steps that you check for the rows and columns. So the subgrid, I mean, it's a there's like a small trick that we can use, which will show you. So if we number, okay, okay, so if we number this 1, 2, 3, 4, 5, 6, 7, 8, 9, choose. Okay, if we also number this 1, 2, 3, 4, 5, 6, 7, 8, 9, if we do this right, so uh, how do we kind of handle the subgrid case here is the question now. So essentially for for each row and each column we would have three subgrids. So this could be 0, this could be 1, this could be 2, and then this would 0, 1, and 2, right? So or we can keep it as 3, 4, 5, 6, 7, 8. So these would be our subgrids in this case. And then let's make it even more simpler. I don't want to complicate. So we can keep this entire subgrid here as 0. We can name this as 1. So these three. This we can name as 2. And this you can keep as 0, 1, 2 for the columns. Okay. So this is 0, 1, 2. This is 0, 1, 2. Okay. So now suppose we want to find out what is the subgrid for 6, right? So in this case, what we can do is you can basically find the subgrid using this particular formula r by 3, c by 3. Since there are three subgrids on the over the rows and three over the columns. Okay, I'm sorry, three over the columns and three over the rows this way. So we can use this particular formula to find the subgrids. So this would give us 6 floor division 3, or, or should be, yeah, 5 floor division 3, and then this would be uh, no, this would be 4 floor division 3, because it's in the fourth row and the column is fifth column. So 5 floor division 3. So now this would be 4 floor division 3 uh, would be 1, and also 5 floor division 3 would also be 1, right? So as you can see, this is the coordinates of the subgrid that we have, and which is correct, right? So this is in the first subgrid along the row this way, and it's also along the first subgrid along the columns this way. So it belongs here. Okay. So if we have another, if you have another set, right, uh, for the subgrids, then essentially, basically, what we do is, if this B or C is in, our subgrid set at position R3, C3, okay, then we return false, else add it to uh, the set sub R3, CR3. Okay, so this is basically how we solve the problem, and we have to go over each of the um, this 81 positions to be able to check whether they're in the right place or not. And even if one of the numbers has a misalignment between these three rules, then we return false. So now let's go to the code. It's like quite straightforward. Yeah. So in the code, right? So we define three, three, s- three, three sets. So one for the rows, one for the columns, and one for the squares. So sublist. So for this, the key would be R divided by 3, C divided by 3, like I mentioned. And for each of the cells in our Sudoku board, if it's a dot, right? So these spaces are uh, these spaces are basically dots. They're mapped as dots in our input board or input array. And if it's a dot, then it's a space. We can continue. But if the cell is already in the uh, the row set for the particular row, or if it's already in the column, or if it's already in the square or sublist at this coordinate, then we basically return false. Even if one of these is false, then we return false if it does not satisfy even one of the conditions. And basically the program finishes right here, so it does not check anything further. But if all these three conditions are true, right, then add we add it to our column sublist. Okay, add so seat subset, I must say, in our column set. We add it to the art subset in our columns, in our rows set, and then we also add it to the squares set. So this is how we do it. And finally, if all the cells are completed, right, so we essentially return true, saying that the Sudoku board is valid. So this was the story for problem 36, and I'll see you in the next one. Thank you.